Example 8.10. Suppose that a market research firm is hired to estimate the percentage of adults living in a large city who have cell phone. Of the 500 people surveyed, 421 of them own cell phones. And the question is asking us to find a 95% confidence interval to estimate for the true proportion of adult residents of this city who have cell phones. So we have to write down some keyword here. We are surveying 500 people. So we know N equals 500. And we are looking for a proportion. So we have to look for the sample proportion. Now our textbook use P prime, and it's the same as P hat in our handout. Those are denoting the sample proportion. And to calculate this sample proportion, we just need to find out, okay, out of the 500 people, how many of them own cell phone? So 421. And then you use a calculator. You should get 0.842. So that's a proportion. And that is a sample proportion, and it's a point estimate. So it's a point because it's one number. Estimate for the true proportion. But in this question, we don't want just have a point estimate, but because it couldn't miss the true proportion. The true proportion could be like 83%. So we want a 95% confidence interval. And how do we do that? We have to call the formula for the confidence interval. And it's in the handout. So a confidence interval, you use this formula. P hat or P prime is the same, okay? Plus minus z, a z-score, times the square root of P prime times 1 minus P prime. And you can call it Q, okay? These two has to add up to 1. And then divided by the sample size. Okay, sample size. So in the textbook, it called this part the error band for the population, for the proportion. So the first thing you need to calculate is the error band for the proportion. Then you subtract it from the point estimate, you subtract it from this number, you get a lower bound, and you add it with this number, and you get an upper bound. So this error bound for the proportion will equal z, okay, times square root of p prime times 1 minus p prime divided by n. Now, what is this z-score right here? It depends on the 95%, how confident you want it to be. And it is true, okay? If you want a 95% confidence interval, your z-score is always 1.96. So you just need to remember this. 1.96 always corresponds to a 95% confidence interval. So for this z-score, you substitute the number 1.96. Okay, multiplication. Square root of p prime, we already have the point estimate, 0.842 times 1 minus p. You can just put a parenthesis 1 minus 0.842, or you can do it on the side. Okay, 1 minus 0.842 is 0.158. And then you divide it by 500. Now you must use a calculator to find out this number, and you want to round it to 3 decimal is fine, so 0.032. So that's the error band. Then you need to perform is p hat subtract, p hat or p prime subtract this number 0.032, and in our case is 0.842 subtract 0.032, and we get 0.81. And then if you add this number to the point estimate 0.32, you get 0.874. And then the 95% confidence interval is just 0.81 to 0.874. And follow the textbook explanation. Is saying that we estimate with 95% confidence that between 81% and 87.4% of all adult residents of this city have cell phones.